Okay, so I think that might have worked. Yes, it did, but not the way I wanted. Okay, so we have sound now, but not all the connections are made. Okay, great. Perfect. I need to set this up so it works. Because in my patch bay, you can see it says, hey, oh, why is it say modified now? Save exactly as is. So I don't want to. Reconnecting? Okay. My patch bay is not working properly. So I just need to take the actual connections and move them back to the patch bay. So Reaper vocals, this has been working for other things. It's connected to many other things, just not to jack. So I think that's the problem. Start with microphone. Edits. 1 and 2. Oh, the name is different. Microphone. Okay. And background edit. The name is, there we go. I think I changed the names in Jack and it screwed around with the settings. So let's save it. It should reactivate. Okay. And it looks like you can still hear me here. Great. Still connected, and more importantly, everything's set up now. Not just microphone left, but also right in the background. Great. Okay. Well, that little side project out of the way, off the video. Let's go back to desktop 2. Transition. Okay. So where we left off, I was looking at this. No, not this. I can't remember. I think it was. What was the last thing I committed? No. Go back 1 commit. Oops. Go back 2 commits. 3. 4. It's in there somewhere. This one, I think. No. Okay, where did I add wrap and unwrap? There it is. Here. Get geometry distance from origin. I remember when I wrote this, I'm like, yes, this is awesome, it's amazing, it works. But I was actually lying. That was because I'm a streamer, and you shouldn't trust me. I'm a guy on YouTube, so of course I'm not going to tell the truth all the time. No, I was really excited to get this working, and I realized later on that this is really bad. Now, one of the problems I realized at the time, the crux of the issue is the way that max works. Because I need to get the maximum value here and the maximum value here, the maximum difference, right? Maximum distance from origin. And that's the crux of the issue, because the max function only accepts 1 argument. So let's go backwards. Let's look at max, and you can see it takes 2 arguments and then outputs an answer, right? So for example, max of 1 and 3. 1 and 3 is obviously 3. The max of 3 and 1 is obviously 3. So it obviously the max of 1 and 3 is not 5, right? So it kind of, flows from there. What I would like, though, what I really want is a maximum function that will take a list of integers, like this, and we'll just output the max of that. We'll just output 5. That's what I really, really want. So that doesn't exist, and it's kind of frustrating, and basically I need it to exist, and because of that I use this getMaxBounded, and this takes a list of vertices and outputs the maximum x and y coordinate, and that's fine and all, in terms of, it's giving me the actual value that I want, but I have to first wrap the coordinates in a vertex, and then pull it back out of a vertex, because a vertex is not really what I want. I just want to do really what I want, the heart of what I want. If you go down through here, you can trace through, go to where that's defined, down here. Get bound 2D. There we go. What I really want is this thing right here. So, and this is kind of an important function. and I need it. And really, I'd like it to be part of the prelude, which I'm not going to be modifying today. I'm not going to be doing that. I'm just going to be doing it the hard way for now. But I would like at some point to have a prelude specific to this project that has all the things in it I need and nothing I don't. But the reality is the built-in prelude's good enough, so I might end up sticking with it after all. But I need to fix this, and another thing I need to fix is it's not here, but like there's something I keep redefining, which is the map both function. So we're gonna put both of those in a kind of prelude. First, let's look at our module structure here. We have the convert hierarchy, the convert folder, the model folder, the render folder. It doesn't go under any of those. It really doesn't go under. I wouldn't consider this core. Like, it's not core to Hascad. It's core to. Yeah, core is the wrong name for it. I shouldn't put under something called core. Oh, we do want to call it basic or something like that. Let me just do a top level module for now. And I don't know, I think utility is the wrong word. I need a word for this. I want to find just the right word, and I think utility is the wrong word. But we'll find out. A base, fundamental, alkaline. Oh yeah, sure. Not what I was thinking about at all. Abovo, what's that? Oh, bear? Bottom. Focal. Foundation. Primary. Primitive. I think primitive is the right word. I think that's the one I'm looking for. Because this isn't stuff that's necessarily foundational. It's just used everywhere. Like, it's not foundational to a CAD. It's just more foundational to programming, I guess. And primitive. I think this is more what I want. What's this mean? Ab ovo, from the beginning.
Ab ovo.
From the egg. Oh, okay, that makes sense.
Ab ovo.
Okay. Cool. I don't know why we're in bottom. Utility. Primitive is the right word. I don't need to keep looking. We can find a better word if we keep looking long enough, but let's just start with a word we have that works. Okay. So I want to edit primitive.hs. Okay. Okay, so max. Now, if I were building my own prelude, I would actually redefine max to work with lists instead of working with just two numbers. Oh wait, I think there is a function that does this. I think it's called maximum. It totally is there already. Oh my goodness, wow. I just kind of forgot what it was. Okay. Okay, so let's start using that in the first place. We won't need primitive for that. We'll ignore that for now. Bound. You know, I don't need to change this. I really don't. But what if I just, like, if I use maximum? What we're doing here is looking for the largest vertex. The one furthest out. Oh, but we're creating a vertex, actually. Because this vertex is not part of the, it's not part of the shape, it's not part of the face. This vertex is just representing the furthest that any part of the shape extends in both directions, x and y. So we're creating a new vertex. and just searching for like the biggest in the X and the biggest in the Y. I don't think I'm going to change this because this is pretty tight. And like there's no point. Like I'm getting rid of the fold R and replacing it with the CMP function. I feel like that's not really buying us that much. We're just getting rid of fold R. And maximum probably is defined in terms of fold R or fold L, and we lose, like by keeping the fold R in, we can control the properties of that later if and when we care about strictness or anything. Anyway, let's just leave maximum alone. Let's leave that alone there. But here we're going to use maximum instead of relying on that. That's really going to help us a lot. Okay. So that's what we're going to do. And then after we fix this function up and decide whether or not to put map both here or not, I think I'll probably still not do that. I think I'll just leave that alone for now. I might put it in there. Then we're going to talk a little bit about direction, about the project as a whole. So stay tuned for that. Okay, so all of this is hot garbage. I want to get rid of all of it. Oh no, I do want the parentheses there. Okay, because it's part of the tuple. Okay. Okay, now, that's all hot garbage. What I really want to do is take the maximum of the x distance and the y distance You know what? The real difference between get bound and what I'm trying to do is, the real difference is the by function. Yeah. It's very similar to that. But that's so primitive that I'm having trouble thinking of a name for it. Let's try. Get No, I don't think I should combine projection and sorting into one thing. I should project first and then sort. And the reason is because the result I want to return is not the original value, but the projection. So if I were trying to, like, I had this problem at work where I was trying to sort these objects based on the translation of their name into another language. So that no matter which language you have in the front end, like no matter which language you're using as a user, everything looks sorted in the list of objects. But I'm sorting by the name of the object. I'm not sorting by the object itself. However, I want to return, like I want to use more than just the name. I want to use the entire object because there's some other properties that are important for creating the UI. So it's really not just a list of names that I want as a result. I wanted to sort by a projection of the object, which is its name. And then I wanted to retain the full object in the list, if that makes sense. So I wanted to sort the list of objects without losing the objects, right? But if I wanted to just retrieve the names and then sort them, I could do that as separate steps. The reason I had to combine the projection with the sorting because it was integral. Like the projection had to happen first, but the sorting had to retain the value it had before projection. So in this case, I don't have that situation. The value I want to return is the result of the projection. So I can just do those separately. There's no reason to conflate those and say, okay, for these two specific primitive operations, I want to create a function that does both of them simultaneously. It's a special case that doesn't need to be there. Just use the just create two separate primitive functions that do the two tasks adequately. And one of those two functions is already defined in the prelude. It's called maximum. So that's one of the two primitive operations I want to do. The other one is I want to get the first vertex or the second vertex. I want to get the x or the y. In other words, by x or by y. Where's this vertex pair thing come from? Okay. Yeah, I want to make note of that. I want to keep using that. Because basically that's my wrap and unwrap functions right there, or that's half of them. Yeah, vertex pair does part of this. Like, yeah, my unwrap functions could have been defined as with that. Anyway, whatever. Okay, so I don't need a wrap anymore. I don't think. Okay, I have a list of these guys. Now what I was doing before here is I have this from origin calculation, which actually uses a vertex, a specific vertex of 0, 0. The advantage of this is it allows me to move the origin later within the space. But I think that, honestly, I think the origin should always be at 0, 0, even if you move it within the, like if you move the origin across this device surface or across the image, the output image, it should still be at 0, 0. The coordinate system should move with it. Okay. So what that's telling me is the position of the origin is relative to the device space, not relative to the native geometry. Yeah, okay. Okay. And the reason that's important is because later, later what I want to do, as I mentioned last time, I want to figure out how in this render parameters information, like in this data type, I want to figure out how to express the origin offset. So what I'm thinking at the moment is because of how the origin is always going to stay at 0, 0 in the native coordinate system, it makes sense that the origin doesn't have a relative position compared to the geometry bounds, and in fact has a relative position compared to the surface, the device surface. So in other words, to truly calculate it, you would take the geometry bounds and convert them to device units, and then from there, from that point, you would then be able to what am I trying to say? From that point, you would then be able to calculate and say, okay, it goes at this place on the device, and then you convert back to native coordinates. I skipped all that and just did all the calculation on the native side just by dividing this by 2, because I'm like, okay, it goes in the center. And that works because this is continuous. This is mapped continuously across the device, and that's always going to be the case. But it makes more sense to think of it in terms of device coordinates instead of native coordinates, I think. Because like I said, native coordinates don't exist without the origin already being defined. So it really doesn't make sense to define their offset from the corner. Yeah. Okay, so that's how I'm thinking about it at the moment. Okay, now back to the specific case we're talking about here. Like getting things working and getting things, I don't know. You could say it's a waste of time for me to rewrite this function since it's working or presumed to be working. But I don't think so. I think it's important for me to understand what's going on here, and I think it's worth the extra time to do this because it's helping me understand other parts of the architecture, other parts of the program. Again, even though this is completely working as it is, I'm not satisfied with it, and I don't like. I really want something that's. I'm not sure exactly what I'm searching for. I'm looking for something that's defined in a way that doesn't reference anything irrelevant or unrelated. And the fact that I'm having to wrap and unwrap this proves to me that I'm wrapping and unwrapping it. Not just am I wrapping and unwrapping it, but I'm wrapping it in a type that is not relevant to the calculation I'm doing. So that proves to me that it's not as primitive as it could be, because I'm wrapping it in an irrelevant type just for the side effects that I can just to gain the side effect of being able to do the correct calculation over the combined type and then unwrap it and get the value I want. Like that's not really good programming. It's effective, but it's not good. Okay, so that's why I'm here and why I'm working on this, you know, this is something I wrote in like what 5-10 minutes at the end of my last session, but it's really something worth focusing on and getting right. Just spending some extra time to think it through. Okay, so and another thing I didn't do here, by the way, which I could have done, is instead of creating this thing here, creating this tuple here, I could have created the tuple at this point between the x dist and the y dist with zip width or zip. I could have zipped with wrap. I could have made a wrap function that wraps both of them. That would have been vertex pair, actually. Or no, it would have been the opposite of vertex pair. Anyway, that wraps both the x and the y. Actually, vertex 2D would have been the correct function. And then I would have been able to do the calculation on both at the same time instead of getting them separately. Actually, that probably wouldn't be too hard to do. Let me do this. Max dist equals, let me just write it there and then not actually rely on it. Equals, unwrapping is vertex pair, get max bound 2D, map, okay, I want to map from origin over from origin calculates both, I think. Oh no, it doesn't. Okay. Oh, okay, I see the issue with that. No, I don't. It's probably the same. Anyway, this will help me think about it more easily, I think, and will help me. If I can simplify this calculation, I can then convert it to what I really want easier. I think it's worth the time. So, map from origin both dist, right? Vertex 2D x y x prime y prime equals vertex 2D, and this doesn't even make sense because we're wrapping and we're wrapping a distance inside of a vertex. Well, I guess that makes it a vector. It's a vector, so it's close enough to I could change this to vector and it probably would be fine. Probably be okay with it then. Dist x prime, dist prime y prime. So in dist prime is going to be dist prime a prime is going to be, or actually, no, let's do it that way. ABS of a minus a prime. Okay. So now we have that dist function that does both of them simultaneously, keeping it wrapped in the vertex. Now then, we want to use that dist in from origin, so then we have map from origin dist, and we can wrap that over both values, and as it is, we can wrap it over the loop, as we're doing. So what I really want is for each one, for each set of vertices, oh, we're actually keeping it as a vertex this time. We're not changing it to, like, the result is a vertex, so we don't need to unwrap it. Or we don't need to wrap it in a vertex because it already is one. And we don't need to unwrap it. Well, no, we do unwrap it here. We unwrap it at vertex pair. Okay, but we don't need to wrap it because it's already wrapped. It's staying wrapped because dist is doing the wrapping right here, whereas x dist and y dist separately, we're not wrapping it. So I was going to do zip width, but I don't need to because this is already a tuple. It's a vertex 2D, which is basically a tuple. It's already a tuple type. Yeah. Okay. So this is the calculation we need, and then we could say that go prime equals max dist loop, right? So that should give the same answer as go. And I'm going to take these and separate them. Boom. Like this. Bam. Because I think this is equivalent to all of that, not counting from origin. That one is more basic. I think it's equivalent to all of, well, actually, to be honest, if from origin is used by both of them, I think this is equivalent to all of that. And it's much easier to think about, even though I still, it's almost won me over, actually. I'm almost won over to this to where I should just use it like that. I didn't expect this. What I didn't expect was that it would be natural to keep, when I combine x dist and y dist into the dist function, I didn't expect it to be so natural to use a vertex there. But I'm not going to use a vertex. I'm going to change this to use a tuple, and we'll get rid of the inner parens. I'm not using a vertex there. Okay. So in order to get max bounded to work, we're not doing a zip width, actually. We're mapping wrap dot. And wrap is going to be x comma y equals vertex 2D x, y. And I'm aware that there's probably there's a generic function there we're wanting to do where we... Oh, it's called map both. No, it's not. It's not quite map both. It's different. But I'm aware that this could be a special... Like, this could be a more generalized function. Anyway. Actually, I'm going to look for that more specialized function. Let's go to Hackage. Oh, no. We want to go to Hoogle. And we want to search for a function whose type is a function from A to B to C, and A comma B and to C. Uncurry, that's it. Uncurry. Ah, I'd forgotten about this function. That's what I want, uncurry. So if I take, for example, vertex 2D, consider that as a type, it takes two numbers and returns a vertex of that number. Right, a vertex with that number, like that kind of number. So let's take the type of uncurry vertex 2D. This takes a tuple and produces a vertex. Okay, that's exactly what we want. So wrap is, boom. And I'm still going to keep the word wrap. But man, I've used that pattern so many times, and I forgot about curry and uncurry. Yeah, I should go through my code looking for those and just replace them with curry and uncurry. That's probably going to simplify things. And honestly, we're getting to a point where I'm almost satisfied with this code. The only thing I really want to replace is the get max bound. We don't want the distance of the vertex from the origin. We want the distance of the x and y components separately. So what I really want, yeah, I think I do want to do this function differently. I'm pretty sure I do. What I really want is a function that will go from a list of this to A, B. Unzip, okay. Unzip width, I'm sure. Okay. Hmm. Well, but I understand why unzip wouldn't exist because you can do that with two separate. Like you don't have to combine those. There's no reason to conflate them. Okay, so. Oh man, this got my brain on fire. This is. Okay, yeah. This is really good. That's a good sign because I'm thinking really hard about this. Okay. So. The first thing I want to do with the loop is to unwrap it. Split vertices. And the type is going to be vertex 2D in, comma, in. That's the type. Okay, and I don't really care if it's a real frac or not. Doesn't matter. List of vertices. That's not more clear. Okay, split vertices loop equals. I bet I can get by with what's it called, point form or whatever. Okay. The last thing I want to do is run unzip. Okay, and I need to create a list of vertex pairs. There we go. I think that does the right thing. Close enough anyway. Okay, so that's the first thing I want to do is get a list of x's and y's separately. And then I just want to find out which one of them is furthest from the origin in that axis. Okay, and the origin is always 0, 0, so I can hard code it because it's just a property of the origin, right? In fact, that's the only property of the origin is that it's at 0, 0. You can have an offset from the origin, you can have a relative origin, but it's not the origin, it's an offset. Okay. Okay. What next? Well, let's just go through this max disk function because really this is the key. Let's bring it up here. And we'll get, just for now, we'll get rid of it. Okay, we're unwrapping the vertexes to pairs. And then I'm sensing a map both here. Before we forget, let's do this. Function of some kind to a comma a. There we go. A to b, b, b. There we go. Okay. There's my map in both function. I'm going to be using it here. At some point I need to split it up into its own separate whatever, but I need to actually make use of the primitive class for that. I'm going to do that later. First thing, I just want to get this working, and then we can do that. Because we're going to make a change throughout the entire application for that. So I don't want it, like it's going to require refactoring a lot of places to remove the temporary map both. Okay. Also, that requires importing control to arrow, but we can do that later. Okay, focus on this. Okay, so we got this part taken care of, sort of. Distance A equals distance AB equals absolute value of A minus B. Okay, that part we've established. From origin equals distance 0. Okay. So I think what we want to do here go equals map let's think about this. We want to go over both of those. I think that's zip width. A to B to C. A, B, C. It takes two separate lists. Okay. Let n equals zip with ID. Okay. Oh, that doesn't work. There we go. Because this new function m, which has it's like zip width, but it already has the zipper function applied. Okay. A to B to C. A or C to B to C. The specific one we chose changes that type, and I'm not worried about that because we chose const, which is just a stand-in function. The point is, I want to figure out curry. Yeah, I want to uncurry. So m.uncurry uncurry m, because we got the A, B to C thing. What's the type of this? Yes, that's what I want right there. Okay. So then we have go equals uncurry zip width. And we need to apply the first argument of zip width before we uncurry it. Dot split vertices. Okay, so that creates this. The uncurry allows zip width to pull it and to do it, which needs a better name. It's going to take the maximum first of all, because it's applied to both sides. But first, we don't have vertices here. First, we're going to take this number and find the from origin. I think that's it. Okay. So first things first, let's comment that out. Don't know if we need loop there. And you can see, like, look how much simpler this is. Like, it's information dense, but it's not all this hacky code here that just does a bunch of crap you can't understand. Like this is harder to construct. It's harder to write, but it's much easier to read. Because this, all the individual operations are very simple down here, but like, what the hell is it supposed to do? You know what I mean? Like, whereas this function, you read it, and it's information dense, you have to read it slowly, but you kind of have an idea of what it does, especially once I figure out the right name for do it. Yeah. But before I do find the right, let's try reloading. Yeah, that's what I was figuring. Something was going to be broken. First and second. It's really simple. We just need control that arrow. Bam. Getting rid of some of our problems. From origin. Cannot construct the infinite type. Cool. Could not match blah with blah. Okay, so I want to just fix the bottom problem first. I'm going to set some types here. From origin. Well, let's start with distance. Where's ABS defined? Num. Num again. Okay, so for any num, we give a num. From origin, num in to in. Okay, fine. Now where am I using from origin? In do it. Now my understanding of do it is maximum requires something to be foldable and ORed. Okay, ORed's the key here. Do it ORed in, num in, boom. We're taking a list of, see, this might be the key here. Yeah, I think the maximum and the zip width are kind of not agreeing well with each other. Yeah. Yeah, I can see that. In to list of to in. Okay. This is not something to do with zip width, actually. We're doing a fold essentially, or an unfold really. So zip width is the wrong thing. Because the result we want to have at the end is not a list of results. We want to have a result. So I think what we need to do is just do it. Yeah, this is not going to type check. What I want to do is find the maximum of this list of vertices, this list of numbers, and this list of numbers independently. I want to map both. I don't think I even need to uncurry. Map both. Do it. Okay. Whew. Get rid of that. Now we need to name do it somehow. We can afford to give it a long name. Find maximum distance from origin. Max distance from origin. Max dist from org. I don't want to abbreviate that way, but I can abbreviate this way. There we go. Works for me. Map both is the most primitive function there. Distance from origin. There we go. Split vertices. Yeah, I mean, this seems fine. Yeah. Let's define split vertices first, and here's why. Split vertices doesn't require any other primitives. Like, when we have max dist from origin, you can see we have to define this dist from origin primitive in order to get this function to work. So we want to put those two close to each other. So that when you're reading it, so when you're reading down through here, right, you get an immediate definition of split vertices. It doesn't rely on anything else. You have to, as a reader, you have to be familiar with the preload function unzip and map, and you have to be familiar with vertex pair, which is it's it's unique to this library, which means you learn it once and you're done. But this max dist from origin, you have to understand this dist from origin function, which is a custom one that's only ever used in this one method, or only in this one function. So it's only ever used here, so you have to always, like, as a first-time reader of this function, of this get geometry distance from origin function, you always have to visit that and figure out what's going on there. Okay. And this distance is not the right one, because this is calculating the distance, what's the word? Diagonally to the xy coordinate, between these two xy coordinates. So that's not at all what we want. We want the distance along the x-axis and along the y-axis independently, which if you combine those is going to be like the Manhattan distance is going to be larger than the straight line distance. So we're not really looking for the Manhattan distance, we're looking for the components of the Manhattan distance individually. Anyway, just a little note there. And I'm content with that function. I feel like that really does better justice to, yeah. What? Oh, let's do that. Okay, move, draw, adjust the scale. I didn't mention where I created this function, so we'll just yeah. What different changes to make? All the changes are relevant to that. So CIA. Okay. Commit all. Modify. Actually, refactor. What did I do to it? To avoid I'm not sure why this is better code, but I know that it is better code. I'm convinced that it is. Okay, now the next thing I want to do quickly, hopefully quickly, is look for every place where we're using map both. Rep, TACL, map both. TACLR. Actually, you know what? CD source, and then map both. Oh, helps if I put a parenthesis there, and that's hard to read with the background, so let's change the background. It's better. Oh gosh, let's change that. Next. That's much better. Okay, well, anyway, it's not getting much better than that. Okay, that's pretty easy to read. So we're leaving the primitive, we're leaving the experiment. No, the experiment's going to, okay, map both. Everywhere it's defined, it needs to be changed. Everywhere map both is followed by an equal sign. Dot star equals. Okay. First things first. To be honest, this doesn't need to be exposed. It doesn't have anything useful in it. Yeah, I'm not really seeing the value in exposing that. Yes, I'm going to overwrite whatever was there. And the change is exactly what I expected. Okay. Okay. Good. I'm expecting that to fail for some weird reason we don't understand. I know what the problem is. Or rather, some weird reason we didn't foresee and take care of already. Which is more accurate. So far, so good. Okay, 10 modules. What a milestone. Okay, so map both. Import primitive instead of control data arrow. Okay. Just go to the previous one. I should really look for uses of first and second instead for uses of map both. What I want to see is in my... We didn't get rid of it. Oh, we did. We made this list shorter. Okay. Yeah, let's, anyway, whatever. So we have left drawing, and let's look for, well, whatever. Drawing, I think, is what's left. Forgot to add it here. Okay. And here's the real crux of it. Does that look the same? It looks the same to me. Okay, great. And let's go back to this. Primitive defines it, we expect that. Swap file, we don't care. Swap file, we don't care. Swap file, we don't care. Our swap files are not supposed to go in these random places. They're supposed to go elsewhere. That's a problem I'm going to fix another day, though. I don't need to fix them today. Move map both. Extract map both. Create new primitive module and I just need to describe what I'm doing. Why I'm doing it is pretty obvious. There's so many benefits to it. I don't need to justify that. Yeah. I'm going to get better at writing commit messages. Yeah, there's so many obvious benefits to having one definition of this that's used everywhere. So many. One thing, we don't have to import control to arrow anywhere except here. And this primitive module could theoretically go in a different, it could go in a different package. So that would potentially reduce the amount of dependencies, direct dependencies we have. Although I think control data is part of the base, so that probably doesn't apply to that specific scenario, but it's fewer modules we have to import across the board. You know, well, not really fewer because we're adding primitive and removing control to arrow, but like down the line, like this data.maybe thing, whatever that is, I think it's probably fun maybe. Yep. I don't know. I could put that under primitive. Like I said, I'd like to define my own prelude that includes important stuff. Anyway, we're good to go. And I don't feel there's any particular value to keeping this open. Okay, so now, as promised, let's talk a little bit about this project overall. So what are we doing and why? Right now, what we've been working on for this stream and the last so far is to render these shapes, these faces to Cairo. And then display them as an SVG. And we're focusing specifically on this test shape, but it could be any shape. And I also mentioned we were trying to detect whether points inside or outside of a shape. So the reason for rendering to Cairo in the first place is to test the quality of the code I'm writing, to be able to just get a visual hint of like, oh, is this code good or bad? You know, I could do more rigorous testing than that. Certainly I could do unit testing and such and get something a little more rigorous, but that's good enough for now. And that may be good enough for my purposes for a long time. So, why am I doing that? Let's look at the body model. Right now we're focusing on faces and trying to verify specifically the edge loop, which is the main part of the face. We're trying to verify that those things behave as we expect. Like when I put in a list of coordinates and say, okay, make a face out of this or make an edge loop out of this, you know, I want to be able to do calculations on the edge loop. I want to be able to display it on the graph accurately. I want to get all this stuff working. Like for example, translation. At some point, I want to be able to translate a face up or down on the graph, and we want to be able to visually confirm that it's worked rather than just having to do it numerically every time. Sort of another goal that I had for this project, which I didn't quite meet, but I came close to, was never to have a show instance. Never to rely on a show instance for these things, to where I'm having to print out an edge loop and verify it by viewing the vertices and like manually doing it that way. Because I think this is a more powerful representation, and trying to verify things by like reading a long line of text and a show loop and a show output is not that helpful. I did end up using trace show a few times, and so I ended up adding show to, I believe, 2 different things here, and probably render Cairo, probably under the monad. Yeah, show instance here for snap mode. Yep. I might have had one for this, but I don't see it now. Okay, anyway. So our ultimate goal eventually is to replace OpenSCAD. But before we do that, we need to get a decent 2-dimensional graphics processing library. And so what I'm doing here is I'm making the assumption, and this is a fine assumption because or I could say assumption, I could say axiom. There's an axiom of this system, which is that each edge loop is independent of the body. Each edge loop has its own origin, right? It has a 0, 0 point there in the face. And then the body itself has an origin as well. And sort of my idea is each, where are those frames defined? Anyway, my idea is that each edge, basically the way you calculate, the way that you would render a 3-dimensional shape, a 3-dimensional body, is you would take the list of faces and you would take the origin of the body. And each body is going to have its own origin. So if you have multiple bodies, they need to be laid out relative to each other in a similar way. But just take the body, start from the 0, 0, 0 in 3 dimensions, and say, okay, take this first face, look at its offset from the body, at that frame, look at that frame, and measure from the origin point of the body to that point in space indicated by this offset. And then at that point, then at that point, you now have the you have the 0, 0 point, the origin point of that face in 2-dimensional space, not 3-dimensional space. So the face itself can just handle 2-dimensional coordinates and do 2-dimensional calculations, and all of that's completely accurate. And then it has to be translated to this 3-dimensional space using the face offset. So basically every face gets translated to 3-dimensional space by using this offset from body. Now, this probably is not the most, well, almost certainly is not the most computationally efficient way to handle it, but what it does allow me to do is it allows me to do simple calculations on edges that are only in 2-dimensional space, and then the only 3-dimensional the only way I have to verify that in 3-dimensional space is by verifying a calculation when I'm taking a 2-dimensional vertex and what would you call it? When I'm promoting it into the 3-dimensional space of the body, I just have to make sure that my offset from body calculations, the calculations I do on this frame, have to be correct. And the reason I call this a frame is because it frames the body within the body. It frames a face within the body. So and it frames a body within the world. So that's the idea here, and I've been focusing on the 2-dimensional stuff to get that accurate and right. And one of my next steps is going to be to triangulate this face, because that's going to be important for exporting to an STL file. And I think my biggest focus right now should be on getting a successful export to STL, because then, so that's my overall focus for this project right now at this time. Because once I have that, every single time I define a new primitive operation inside of my world, inside of my model system, I automatically can start using that in an STL file, in a normal CAD program. So like, oh, look, here's a FTB. I have a CAD program. I'm going to open it and see if, oh no, this is not, never mind, that's not a CAD program. Never mind, cancel. But when I export the STL file, I then have the power of a normal CAD thing, and starting with this part first and getting the exports correct multiplies my effort the most, because then I get to that MVP very, very quickly, where I have a working system that does almost nothing, and then every time I add functionality to it from then on, it's going to be more and more productive. Because the complicated stuff is not really exporting to STL. The part I'm mostly interested in is introducing parallelism in actually calculating the model, and actually also in rendering to an STL. I want to be able to take, for example, for a body, when I'm trying to calculate where each face exists in 3-dimensional space, I want to be able to do that simultaneously for every face independently of the other faces. So that just requires me to spin up for, let's say, 5 faces. I spin up 5 separate threads and run it. Or maybe I have a pool of 5 threads, and maybe there are 10 faces in each, and I do half of them at a time. You know what I mean? Or something like that. I want to be able to be able to process things in parallel and do things like transformation matrices and apply all sorts of stuff in parallel. Because theoretically, you can also apply, like even inside the face, there's opportunity for parallelism. You can apply a transformation to every vertex independently. It doesn't rely on the other vertices in order to do that most sorts of transformations you want to do. And I don't just mean like and when I say transformation, I'm not just talking about like just moving the thing and scaling it and rotating it. I mean like any sort of modification you want to do to that point. A lot of them can be done without reference to other points. Yeah. So that's kind of the focus. Is right now my focus is on 2-dimensional space and getting that rendered quickly. So I've gotten that part done. That part's out of the way, and now I can start now I can start performing 2-dimensional operations that are necessary for the STL output in 3-dimensional space. I can start doing those now and seeing the results in Cairo here. I've got it rendered here quickly, so I can quickly test whether it's working. Because my next step is to start triangulating, to break this complicated face up into triangles so that it's appropriate for the STL format. And also that makes it appropriate for a lot of other things, like basically the industry has standardized around triangles, and using them, it simplifies a lot of things for people. Like, so basically, this complex face will become multiple simple faces, and by simple face I mean a triangle. So 1, 2, 3, 4, 5. I think at least 5 triangles are necessary to represent the shape, the way I count it. Anyway, so that's where we're going. That's the direction of this project right now. Now, historically, though, I have a lot of pre-existing work. So if we mosey outside the core and we look here, we have RC1. So release candidate 1 is what I called it. And what I'm working on right now, as I've shown before, is release candidate 2. And basically, like, I was working this project a long time ago and made some headway and then abandoned it. So I haven't even looked at RC1. Like, I haven't even looked in here and tried to do anything with it because I'm like, no, I want to start from scratch. And it looks like what I'm mainly doing. Anyway, I don't know what I'm doing here. So I was wanting to look at this for comparison point later on. It looks like I did a lot of work to convert between polar and Cartesian coordinates. And that will be important to me later on when we're actually trying to construct bodies. Because I wanted to find primitive functions that allow you to construct a circle using polar coordinates, which is really easy for circles. And then I want to save the vertices in Cartesian coordinates, which is easier for other operations, and also easier for integrating them with other shapes that aren't easily expressible in polar coordinates. They don't have like linear expressions in polar coordinates. So that's the idea. So base data. Let's tree this sucker. Okay, yeah. Okay, here we go. Data decimal floating, edge transformations, union, hash map, STL, and SVG. Rendering the SDL, rendering the SVG. Yeah. Okay. So I was doing a lot of the same stuff. Yeah, let me see what that edge transformation thing is about. Vi RC1 lib base data edge transformations. Oh gosh, this is a really complicated type too. That's one of the reasons I didn't go back to that work and just start from scratch there, is because I remember making a type so complicated that I couldn't think about it properly. And this time I decided to go in the other direction, just stick with a very simple type. These complicated types can be very powerful, but they can also be very expressive. But like you can have a type that expresses everything you need it to, and then you just aren't quite sure how to use it effectively. Or you can have a type where it expresses almost everything you need, not quite, and you can't figure out how to get to express that last 10%. Reified edges, oh dear lord. I think a reified edge, if I'm remembering correctly, was something that had been converted to a specific, where I've committed to a specific resolution. Like, for example, if you have a circle defined in polar coordinates with an origin point and a radius, that circle has infinite precision. You know, it has infinite precision, at least in terms of where the arc is. Right? You can calculate to an arbitrary level of precision, an arbitrary number. You can use an arbitrary number of points on the circle, along the circle, to approximate it. But once you've reified it, if I remember correctly, it means that you've taken all those points, converted them to Cartesian, and you've committed to a specific resolution. Because you can't go to infinity. You can't calculate every single point on the circle. You have to stick with an approximation. And I think it was just a generalization of that idea for the circle into basically anything. Like, I think I if I remember correctly, I had like an abstract notion of shapes, and then you commit to a resolution, like a square, like a cube, or a rectangle, a cube or a prism or whatever, and you commit to the resolution at the latest time you can, and at the time where you know what the resolution should be and where it makes sense. Like so that was the idea. Okay, so I'm kind of curious about this at this point, but it's a little bit too early to start focusing on that. And if I explore this too much, I'm going to get excited about it and start trying to do it. So I think I'm not going to do that. What I am going to allow myself to do is to look at my render SVG function and see what that does. It doesn't use Cairo. Oh my lord, I was doing this all by hand. Oh yeah, I was. Okay. SVG element. Okay. So it looks like I created basically this own domain-specific language for just SVGs and said, okay, well, here are the things I can represent in SVGs. If you have a shape, you need to translate it to one of these in order for it to work. Face to SVG. What's the type of this? It'd be nice to know that type. Root. SVG box element surround. Okay, so SVG, we have a box, a version, and a list of nodes. One element. A list of nodes. A node is either an element, would be one of these, or text, or it's a comment. I don't remember what the text was all about. But a comment can be any arbitrary node. In other words, you can comment out SVG stuff. Oh, I think I know what it is. If you want to comment out text, fine. You just have a text node. But if you want to comment out other code, you have to have a provision for that. Okay, I think it was just a matter of parsing SVGs and representing it faithfully. I think I was trying to represent faithfully everything you could have inside an SVG file, which is probably a little bit more than I needed. Okay, attribute. Right, we need to represent those somehow. Path. M and L. Oh, move and line 2, I think. That's what that is. Yeah, so this is pretty cool. And you can see this is completely separate from the main this is separate from the main representation, right? Because this is literally just effectively unparsing an SVG file. Like we're serializing the SVG using a custom shape type, like a custom type of shape, or really not even a custom shape type. We're taking a face that we have and we're converting it to an SVG right here in this method. But what we're doing instead in the new code is we have an edge loop essentially, and that's what we're rendering to SVG. So we have essentially a face, right? A face independent of its body it's connected to, which means the offset doesn't apply and the normal doesn't exist because it's two-dimensional space. So a face, irrespective of anything else, and we're rendering it out just using the list of vertices of that face. I think this is better. What this means, though, well, I don't know if this is a limitation or not. Well, interesting. Before, I was representing a face as a list of points and a list of edges, even though, what's up? You ready? Okay. I'll be there in a second. I was representing them separately, even though the edges contain the points and the points contain the edges. Like you can calculate the edges from the vertices, and you can calculate like it was redundant information. So that was probably a flaw. Required. I mean, obviously it's convenient to store both. It's convenient to store both, but it's probably a good chance to get things wrong. It's probably better just to calculate one from the other and just store one canonical representation. Okay, so that's a good look into the past. I probably won't be directly using most of this, except potentially I may want to rebuild, like after things are working, I may want to redo my types to be more high level. So like basically just take a list of functionality that works properly, that does what I want, and then change the types slowly to make it more and more abstract. Like I was thinking, one thing I may eventually do is take vertices. See, I've got vertexes, which are 3-dimensional, and vertex 2D, which is 2-dimensional. I could just define vertex. I could have types like this, where you have to specify type vertex 2, right? Where the 2 represents the number of dimensions, or vertex 3. So you would have like vertex 2 double, which would be vertex and then some double, right? Like 0.58, right? Or you might have a vertex 3 double, which would look like this, 19. You know, and so basically I wanted to set it up so that these would be valid valid values for this type. And maybe it would be set up like this. This is probably more accurate, because the only way really to get arbitrary number of arguments would be something like this. Well, that's not true. There are weird ways to do it. But anyway, this is kind of what I was thinking I would eventually do. But honestly, for now, just having the separation between the two is just a minor inconvenience, and it may never be a problem. It really may never be a problem because of the way I'm separating things in my mind, where I just spent a whole time discussing how we're going to render faces and learn how to render faces, and then go back to bodies and also do a translation between the coordinates of the face in face land and the coordinates of the same face in body land, if that makes any sense. Like the two-dimensional coordinates of the face, irrespective of any other object, and the three-dimensional coordinates of that face offset from the body. But I think the offset thing is pretty powerful, and I think it's a good separation, even though it intrinsically adds a little bit of overhead, but I think it's worth it in terms of making the algorithm simpler. And simpler algorithms are going to be easier to parallelize. Because we don't have to think about handling faces in many different angles in a third dimension. We just have to handle one plane, not every plane. So I think that's overall the best. Anyway, I'm rambling, and I need to go take care of some stuff. Keep the wife happy. So I'll catch y'all later. Hope you enjoyed that.